Good morning and welcome to KETIV AVA. I'm your host, Nicole Morris. We're happy to present Electro-Mechanical Design. We chose this topic because we heard from many of you that you are having to do rework from your electrical design to your mechanical design. Often there's a miscommunication, or even sometimes it's the same person having to do the work at different times. This solution allows you to have these two designs communicate simultaneously. These products are already included in your Product Design Suite Ultimate. You have Inventor and AutoCAD Electrical, which will be involved in this presentation. So with that, I'd like to introduce Randy Brunette. He's a subject matter expert at Autodesk on all things AutoCAD Electrical. So Randy, take it away.
Nicole already covered many of the topics that we're going to cover today, the interface between AutoCAD Electrical and Inventor Professional, and how we're going to communicate and coordinate that communication between the physical and logical designs, between the mechanical and the electrical. Now, some of the extra goals that happen with this as well is that we're able to determine the paths for the wires through the component or through the machine. And many times, especially in space restrictive areas such as airlines, mining equipment, this can be a vital part of your design component. And also we can develop the wire cut lengths for your automated operations. The end result of this, of course, is that we're in the digital design environment and we can achieve better design products, lower costs, and help you design the way you want to create components. So for those of you that are not familiar with AutoCAD Electrical, just going to do a quick overview of the product. AutoCAD Electrical is an industry-specific design tool for the control industry system. It's not restricted to that, but that's really what it was started out as. Control panels, push buttons, but it can do a variety of things, such as the cabling in server rooms and so on. One of its strengths is that it's native to the AutoCAD environment, meaning it is built on top of AutoCAD, means it's completely compatible with the AutoCAD drawings. It's also readily configurable. It comes with about 17 different symbol libraries. It has a very open architecture so that you can adjust the software to make it work the way you need it to. And it's fully portable. Everything we have is generic files. So the drawings are standard DWG files, can be opened by anything, AutoCAD LT, anything that opens and views DWG files can work with the AutoCAD Electrical ones. Nothing is proprietary, so it doesn't have any specific codes. Everything is generic. The reference files are ASCII or Lisp or Microsoft Access database files. And another great benefit, it is really tightly integrated with Inventor, what we're going to show today, raster design, so you can manage and work with your scanned or legacy files, and of course our data management system, Vault. Autodesk Inventor, probably even more of you are familiar with that, is the 3D design tool from Autodesk. It's a great tool for mechanical design and simulation, and those features are getting more powerful all the time. Again, part of that digital prototyping revolution so that one person sitting in one chair can do all of those different tasks. Inventor automates that, or provides the advanced geometry and parametric design environment, making the designs easier and faster to create all the time. And of course, since the designs are intelligent, we can create drawings and reports directly from the model, and they're all synced together. So if we change the model, the drawings and pieces update with it as well. And of course, it is also tightly integrated with AutoCAD, AutoCAD Electrical, Vault, and with any CAD, the list goes on and on. SolidWorks, almost every competitive 3D design tool can also be imported and edited and worked on inside of the Inventor environment. So how does this electrical and Inventor interface really work? The first step is going to be through the part catalog database that comes with AutoCAD Electrical. Inventor also accesses and uses that data and that information. It's basically just added an extra column onto the table so that now the part number knows what the 2D symbol is going to be used for inside of the schematic and what the 3D symbol is going to be used inside of Inventor. And again, this is all integrated with cable and harness between the two softwares. Now, the way that works, in addition to the part catalog database, is we're going to create an EMX file. This is a very simple file. All it really contains, this one file that we create, is the paths to the electrical project and to the Inventor assembly. From there, the software, the interface system, creates some logical snapshot files for the electrical side that hold the electrical data. So this file is the one that creates or extracts the information from the electrical project and presents it to be available for the Inventor interface. And of course, the Inventor software also creates its own snapshot file, in this case the physical one, that extracts the information from the Inventor assembly, and those two files through the software now communicate, creating our whole linking process. This is really the key to how the software is going to work. So that's a real quick overview. From here, I'm just going to jump off into our live demonstration of what the software is going to do and how it's going to work. So I'm using a simple control panel assembly, and we're going to start in the Inventor component. You'll be able to see both of these happening at the same time. It's a bi-directional workflow between AutoCAD Electrical and Inventor. So whatever I'm doing in Inventor, I'll be showing that the same kind of workflow works in AutoCAD Electrical as well. Our first step is to go to the Electro-Mechanical tab. We're going to create that link file. So the file name I'm going to do, we're going to create a new one. I'm going to give it I want to create a new one. So let me break this link from my practice session this morning, and I'll start a new one. Give me just a second here. So I'm creating this new file. I'm going to give it the name _EMX. The EMX file and the EMX name just stands for Electro-Mechanical Interface File. And the folder I'm going to place it in is just my Documents folder. This file just has to be located someplace that both users would have access to. So I placed it, just called it Shared EMX Files. And that's my step. I'm going to save the assembly file. It's creating that file and the links, and you can see here is the EMX file. The Inventor enclosure assembly that I'm working on here has been created and saved into the file. Now what that does is really just started the process of communicating to the AutoCAD Electrical area. From here, I'm going to insert a component into my model. One of the tools that's now in the new version of Inventor is the Electrical Catalog Browser. So this is the part catalog database that comes with AutoCAD Electrical. It allows me to create the settings, point to where I have the database set up, so it can either be a company database or a project-wide database. And in this case, we're going to insert a motor starter. So I grab that motor starter area, in part numbers, and it's looking up this component. Notice as I select it, the image has appeared for that component to be inserted into the assembly. This same electrical catalog browser is the one used inside of AutoCAD Electrical, and you'll see that as I move to that version. From here, now that I have the component inserted into my assembly, I just need to constrain it using the standard Inventor tools. In this case, I'm going to use a joint command and place it onto the holes in the assembly. And also just an angle command to get it pointed off into the right direction. All right, so that portion showed how I use the part catalog database from Electrical to grab and insert parts into my components. Let's take a quick look back at the Electro-Mechanical database or tab, and you'll also notice that there is a location view here. This location view shows me the components in my assembly organized by where they're installed and the component names on the piece that I'm putting into the assembly. For example, here's the motor starter that I just inserted, and it doesn't have any installation or location code values assigned to it, so they're both ends up with question marks. Let's edit that. So I'm going to right-click over the component and select Electrical Properties. You'll notice in the dialog box that appears that we now have electrical kinds of properties that can be assigned to this, including the installation and location codes. And as I'm changing these, when I accept these values, you'll notice how it'll change from the question mark area here into my ElectroCAD assembly. We're also going to assign the part number to the component as well. Going back through the motor starter, kind of using the same process as we did before. I'll select Eaton, do the search, grab the part number information, have that all assigned to the component in the Inventor assembly. All right, now the last thing I'm going to do before I leave here is to sync this up. Now this can happen automatically. You can set timers to be able to do it. During the course of this presentation, I'm going to force the syncing just so that we can move faster between the different components and you can see the updates taking place. All right, now here we are in my electrical assembly. The first thing I'm going to do here is also link it to that EMX file. So I select on my Electro-Mechanical tab and go to the link setup. Now we've already created the EMX file, so I don't need to create one, but I do need to link to it. So I'm going to move to the same directory, select that to open. And here's the linked components. Again, it's giving us all that information, both the WDP file from AutoCAD Electrical and the Inventor project that we're working with. From here, I'm going to slide down to the Location View tab. I want to point out that in this area and in this location, we now have both the mechanical, which shows up as the 3D box, and the electrical components that show up as this round electrical coil symbol. Now you'll notice that they're duplicated because our job is to tell AutoCAD Electrical and Inventor which components are all supposed to be linked together. So we can do that in a variety of ways, and we'll show a couple of those as we're working inside the environment. So the first one is I need to insert the motor starter into my electrical schematic. So what I'm going to do is go to the motor starter tab, that symbol in my location view, and insert that from the catalog browser. Now remember, that was kind of the same command that I used in Inventor. The difference is we've already inserted this. It knows the information that was assigned, so it automatically found the matching information, the E number and the part number, for insertion into my component. So I grabbed the appropriate symbol for it and insert it onto the line. And notice that AutoCAD Electrical Edit dialog box appears with all of the appropriate information, same information that we inserted into the component before in Inventor. All right, so and once I've done that, now I have the electrical component inserted into the drawing. The mechanical component is linked to that, the Inventor physical portion, and you can see how the symbol is changed to a link symbol instead of the box or the electrical symbol, showing you that they're combined together and synced. Next, I'm going to slide down. We have these 4 terminals that are listed here, and we can see there's matching ones inside of the location view. So I'm simply going to right-click on the logical one, or the physical one from Inventor, and tell it I want to assign to the existing in the drawing. So this way, and just repeat the process for each one. What this enables us to do is maybe the descriptions and the tag names don't match as conveniently as I have in my drawing here and in my data set. So you can just simply say, look, I know this part should match up with something that's in my drawing, so I can just pick on it by the visual clues, not necessarily by the tag or the name that are values in here as well. And so now that I have linked up those pieces and those components, my next step is to insert something into AutoCAD Electrical and then move back to Inventor. And we're even going to do something a little bit more. In my Inventor menu, I'm going to grab a component. In this case here, it's going to be a capacitor, and insert it onto my schematic. From here, I'm going to do a catalog lookup for that part number. And you'll see I don't have any part numbers for capacitors in my database at this time. Now I did that intentionally so that I could show you how we can create those links between the different components. I start the editing operation and now start adding the new values for this component. So I'm going to enter a part number. In this case, I'm just kind of making up the stuff that's in here. and case size. So that's just the bill of material information, right, that you'd want to see in your bill of material reports and so on, the information about the component. Next, we'll slide over to the right, and you'll see these columns here, the 2D symbol and the symbol 3D. These are the categories where you start linking the components in Electrical and in Inventor through using the part number of the component. So for what I'm going to do, I'm going to skip the 2D one for now, because I'm going to show you some of an automated feature inside of Electrical, and enter the correct name for the component in Inventor. So I have this part saved. I know what it is, capacitor IPT. And just as an extra step here, I'm going to add the coil pins that will show up for that component. Once I have the information set, I simply approve that part number. It gets added into our catalog database, and now I simply select that to add the information and transfer it onto my component. So here's the part number. We can see the location codes, pin numbers, and so on. Notice this now. I intentionally didn't add the symbol name for AutoCAD Electrical, but because I'm inserting it, AutoCAD Electrical realizes it doesn't have that name mapped to it, prompts you for that, if your approval, to add it into the database, and now we have that set as well. So it knows what the electrical symbol is and what the Inventor symbol is for this component. Now earlier I mentioned how we could set up the settings and it would automatically save. In our project manager on the location view, underneath the sync settings, we can tell it to sync every 15 minutes or to sync on every save. In the purposes of my demonstration, I'm moving back and forth very quickly, but usually this 15-minute time frame or this saving operation will be more than adequate for users to coordinate and work with one another. And the result will be is if either one makes a change, this red marking appears on the components. This indicates that something is different between the two components. It could be something as simple as a descriptions tag, or maybe our case, we have wires attached to the components in AutoCAD Electrical, but we don't have them attached in Inventor. In either case, it's kind of telling you that we need to do something to link those together. Now I finished the sync operation, and notice that the cap that I just inserted here, the capacitor, does not have a matching mechanical component. So from here, we're going to move back to an Inventor, sync to tell it to gather that information from AutoCAD Electrical. By the way, remember when we changed those location installation codes on that motor starter? It's now been moved over to the correct area, M6, on our assembly. And notice here's our capacitor item. So from here, we have this linked up. I'm going to insert that capacitor using the catalog browser. Now this is going to use that information that we just entered to grab the part number and the piece with it. Let's see, I just want to close that. We'll find the part number here. Well, I'm not sure what's happening here, but I know we're running out of time on our presentation, so I'll have to come back and check that. So I'm just going to continue on with this. There's a few more things I want to show you yet about this. Number one, I'm going to right-click on my electrical components and assign that to the existing pieces in the assembly. Notice we have a plug and a jack. In the electrical assembly, I inserted both of them, but I only need the mechanical one, or the jack, inside of my assembly here. From this, I'm also going to pick onto my connector there, and now everything is linked inside of here, except of course for the capacitor where my symbol isn't showing up. I must have cleaned up one too many files this morning. All right, so now that we have this information available, our next step is to create that wire connection and the pieces between the two. So we'll simply come up to our cabinet piece, tell it I want to create a connection. If I just start without having a harness active, it will automatically start creating a harness for me, or I can activate the harness for the editing, and now it used the routing and the pieces that I have already created. So now when I come up and create that connection, the wires will automatically be added to it as well. The wires inside of Inventor will go from the shortest distance. At this point, since we haven't told him where to route yet, They don't know to go through the paths. That'll be a second step we're going to create. So at this, here you can see how they've been added and go directly from one point to another in the shortest route. We have a great auto routing tool. Once I have the paths in there, now I can start that command and Inventor will take the wires through the nearest segment opening to wherever the wire is going to be connected to. So we can see how that's set up in here, except I have these 4 stray wires that weren't quite coming off of this PJ7 connector that didn't quite work. So we can always manually make adjustments and changes to this as well. In this case, I'm unrouting those 4 wires from where the automatic routes set them. And this gives me the opportunity to show you how to add a new segment into the component to route it through the assembly. So from here, I'm just setting an offset distance and adding work points to guide this segment closer to the connector. From here, I can just run my automatic route command again. And the 4 wires will now be routed correctly through the components and through the pieces. Okay, so why did we want to create that work? Why do we want to route those components wiring? There's several reasons. I mentioned several of them during the introduction about how space requirements in certain applications can be important, or creating wire harnesses or wire lengths. Since we are in a 3D environment, we can easily do that. And in addition to that, we can also use the tools in Inventor to start creating the wire harnesses. To do this, I'm using a nail board command. Nail boards are where they take this, literally take a piece of plywood and drive nails in and route the wires through this to create those harnesses for the application that they're working with. It's still being done today. Companies many times have racks of pieces of plywood with the components or with nails in them storing to create their various harnesses. So here's that harness assembly all laid out flat, and this is a real-life, real-time, one-to-one representation of that harness. It's taken all those curves and pieces and kind of laid them out into a flat area. From here, I'm going to move to my nail board part, and I want to add a couple of these harness dimensions. And I want to do this just to show you the intelligence that's built into this harness area. So by picking between these 2 points from here to here, that distance is 36 inches. I'm also going to pick the end of this wire and run down here at 3.5. Okay, that all makes sense. But also watch what happens when I pick from the original point here up to the end of this wire. This dimension is laid in not as a physical dimension, the distance-wise, but as the actual length of the wire. Notice how if we take the 3.5 and the 36 here, we come up to approximately the 39 inches. So it's actually doing that intelligently for us. And of course, like any of the Inventor design tools, we also have things like the broken sketch entity tool that allows us to take out those long segments that really don't communicate any design intent or any design information to help it fit better onto the drawing assembly itself. And notice the dimensions still stay accurate as you would expect them to. And this drawing is the recreation of the data that we created from the 3D assembly. So that means it's intelligent. We can add the information from the assembly, such as the pin names or the pin components to help document this piece. Or even if we wanted to, we can finish the sketch here and also place in connector views. It's kind of hard to know where the wires are going to at this point, but with the 3D tools, we can easily add wire views, wire spot, where the wires are actually going to be in the component or in the location. So you can see here we have the motor starter, connectors, and so on. Also, so that information here can be actually used to help create this wire assembly. Also, we can take all of this information, move back to AutoCAD Electrical, or in either system it would be. Before that, I want to jump back to here and sync this assembly. Move into Electrical to get all of that information updated. And you'll notice that many of the red marks have disappeared. You'll still notice that these two are here. These are here simply because in the physical world of Inventor, I've shown the complete connector, but in electrical, I'm only showing portions of it. So it's telling you here that something is different between the two. Now when I select up in my Details and Connections tab, all of the appropriate information for whatever component or piece I'm selecting appears. Under the details information, here's your bill of material report, your information. If I select on the Connections tab, this gives me the actual wire from to information. You can see that being displayed throughout here, including wire types, wire gauges, and wire colors. And I can also add a wire length field into the report and get that information in as well. Now remember, this is currently in centimeters. That's why it's shown very accurately for you, obviously much more accurately than you need. And then from here, we can simply export this out to ASCII files and so on for editing. Okay, so that kind of concludes what we have done in this portion. I'm going to run back to my slide here quick and move on to the summary section of the slide. So, and during this presentation, we showed you how these communications can be set up between the physical Inventor software and the logical AutoCAD Electrical designs, and how that's a real live seamless integration, automatically updating between the two. By creating segments, you can route the paths through the wires, through the components, through the machine, or through a cabinet. Those segments will automatically change size depending on the wire sizes that you place in. And we've also shown the dimensions that we can either place on in the nail board drawing or by extracting the actual physical wire lengths back into electrical. And of course, they're also still available in Inventor as well. That concludes what I was going to do for the demonstration, and we'll move into a question and answer.
Thank you, Randy. That was great. So if you have questions, please look to the side. You have a GoToMeeting panel, and there's a section where you can actually type in your questions, and I'll go ahead and read them off. So I have a few that have already come in, so please continue to add to the questions. So let me just start. Randy, AutoCAD Electrical symbols, can you connect them to virtual parts in Inventor?
Yes, I believe so. I haven't actually done that myself, but they can be connected to anything that has wire connection pieces and electrical properties assigned to them. Okay.
So he wants to use virtual parts for things like splices, terminal seals, and things like that. I've often seen some of these things modeled, but there may be a reason to have them as virtual components as well. So we'll check on that one for you. Good question. That was from Kelly. Thank you. Another question also from Kelly is, can you link hydraulic schematics and models to each other?
No, not at this time. The symbols have to be schematic type symbols. Now we could replace or just add, what happens with that is that the WD type attribute has to be the blank version for the schematic symbols. If it has the ID type in there for a hydraulic symbol, then it's not recognized on the interface between the two.
I see. Okay.
It's something we're working on. It's on the list for in the future.
Awesome. Very good. Okay, so another question from Hintran. Let's go ahead. Can Inventor or AutoCAD Electrical generate labels for wires showing from to once wiring is completed?
Okay, so the from to functionality, Inventor cannot do that. Electrical can, but you need to do a little bit of extra programming with it, like a workaround for it. Out of the box, AutoCAD Electrical only adds a single wire label, a single identifying part, but we have some workarounds, some Lisp routines that you can try to create your own wire labels and have that automatically update. Contact Nicole to get that, and I can give you a pass along that information.
Awesome. Is there a way to regenerate the EMX file in case it gets corrupted? This is from George Garcia.
Yeah, so the EMX file, it can be redone. You just have to, the information is stored within the drawing and within Inventor. When you relink those components, you may have to go through and tell which components are linked back together again. To create the file, my real suggestion there is to use Vault or your data management tool to update and add that and back up that information. Sorry about that. In the case of AutoCAD Electrical, if you've created that EMX file, Electrical knows about that and will automatically be added into Vault when you check in the project. With Inventor, you have to manually manage that EMX file and make sure it goes into Inventor as well.
Okay, excellent. So is it possible to store this database into the library into Vault, or to be used for all team members and not only for one person specifically?
Okay, so I assume you're talking about the AutoCAD Electrical database that we'll be working with. And while I shared it just in my documents folder in a shared directory, whenever we're using multiple users with an AutoCAD Electrical environment, we highly recommend that that database is in a shared location. And that means it should be available to everybody. In this case, since you're doing this interface, not only the electrical people, but also the mechanical ones as well. So the answer is definitely yes, you want to share that file with everybody, not with just a single user.
Okay, and that doesn't necessarily have to be in Vault, or can you put that in Vault as well? Or
you can put the database in Vault as well. If that's especially useful, if you want to restrict who has access to it and who can make the changes part, because then now it can be checked out and placed in, it can be used in Vault as a read-only file for the general population, and then your librarians can have their properties to check, or the permissions to check it out and check it, make changes and check it back in. In a non-Vault environment, it would just be on a shared location, and you can set up kind of the same thing with just applying permissions to the folder, allowing a couple of people to make changes to the file, and the rest would just be read-only.
Okay. And another one from Kelly, is there, let's see, is there a inventor part number linked to, is the inventor part number linked to AutoCAD Electrical? I think it's the manufacturer part number, or is it?
Well, I think they're both the same in this case, right? If we have a part number assigned to it in Electrical, that same component in Inventor should have the same part number. We don't provide a direct way of doing it to map them if they would be different. I can't see where they really would be at this time. But if they would be, we can handle that in the same way that we would handle the company part number versus the manufacturing one. So if you're an OEM producer, sometimes you might purchase parts, relabel them with your part number to provide that documentation to your customers. That would be the same workflow we would set up for if you had different part numbers for Inventor and for AutoCAD Electrical.
Awesome. So I think we're good to go there. We might, if you have additional questions, you're welcome to send them in to lifeline@ketiv.com, and we'll get those answers to you. And if we have to connect with Randy, we can do that as well. Great presentation, Randy. Thank you for joining us. And we're going to go over to some action slides if you want to hang out for a little bit. Let's see. So also you can get more about Randy if you go to au.autodesk.com. You can search Randy Brunette, and you can see some of his past electrical classes. Very informative. Like I said, he's got years and years of data on there for old classes. A lot of them are recorded, and some of them are.
One thing I'll mention as well, sorry to interrupt, Nicole, but the representation or the presentation I just gave now is also a class I taught at this year's Autodesk University. And the really cool part about Autodesk University is not only do you get to see the video, like a recording of me doing the presentation, but also the data sets and detailed instructions are there as well, so that you can run through the presentation yourself.
Nice. Very good. Thank you. Okay, so I wanted to bring up our Facebook page, Autodesk Virtual Academy. So if you go into facebook.com and type in Autodesk Virtual Academy, it'll bring up another way to find out what's going on with the topic, what's the buzz about, what's happening, a little bit of Q&A on there. We'll post our videos and our YouTube information. We have a presentation coming up that's not part of AVA. It's actually a webcast that's going to be on Tuesday. It's regarding integrated product development with Product Design Suite. This is going to be on March 15th at 10 a.m. The idea of this presentation is to actually show those of you guys who have Inventor already you have product design suite and you're only using one of the tools in it. So maybe you have product design suite, but you're only using Inventor in it. So what are these other tools and why are they valuable to you? So it's giving you an idea of what other things that you can do with that in the box and develop those workflows. And then also, if you don't have this suite and you just have one of the flagship products like Inventor or AutoCAD Electrical, you can look at the suite and see how you could do things like what Randy showed today, is integrate the tools back and forth. So we look forward to seeing you all on that. Let us know if you don't have the information to get signed up, but watch out for that from coming from Anthony. We have Autodesk University. We have more details for the class. You can also get information at knowledge.autodesk.com. So you can contact us for additional classes. We have an electrical class that's coming up in April. Those dates are posted, but if you need more information about that, just let me know. All right, so with that, we'll go ahead and leave these up. You can get all these videos, these recordings on YouTube for KETIV. And there we go. So very good. And if there's any questions, again, let us know. You can send it to lifeline@ketiv.com or give us a call. Thank you. Have a great day.